young astronomers and future engineers. Today, we're embarking on an exciting journey through cosmic space with our favorite Disney heroes. Imagine this! Mickey Mouse, Minnie Mouse, Donald Duck, and Goofy decided to build their own space station and fly around Earth. But for their station, not to fall or drift off into boundless space, they need to know something very important about movement in a circular orbit. What is an orbit? Imagine Mickey launching his spaceship. It doesn't fly straight up like a firework rocket. Instead, it starts to circle around the Earth. This path along which a spacecraft or a planet moves around another larger object is called an orbit. Our Earth, for example, moves in an orbit around the sun. Why doesn't the spaceship fall to Earth? Here, an invisible but very powerful helper comes to the rescue. Gravity. This is the same force that makes apples fall to the ground and keeps us on our feet. The Earth attracts everything near it. But if gravity pulls the spaceship towards Earth, why doesn't it fall? The secret lies in speed. Imagine Goofy throwing a ball. The harder he throws it, the farther it flies before falling. It's the same with a spaceship. It's launched at such an enormous speed that it's constantly falling towards Earth. But at the same time, it misses it. It moves forward so fast that the curvature of its path marshalls the curvature of the Earth. This is movement in a circular orbit. What's needed for a perfect orbit? Speed. As we've already said, very high speed is needed not to fall. This speed is called first cosmic velocity. For Earth, it's about 7.9 kilometers per second. That's like driving across Ukraine in less than 10 minutes. Gravity. It keeps the object in orbit, preventing it from flying into open space. Centripetal acceleration! This is the acceleration that constantly changes the direction of the object's movement, forcing it to move in a circle. Imagine Minnie Mouse spinning a balloon on a string. The string creates a force that pulls the balloon towards the center, which is why the balloon moves in a circle. In the case of a spaceship, gravity performs this role. What if our heroes forgot these rules? If the speed is too low, Mickey's space station will simply fall to Earth like a stone. If the speed is too high, it will fly away from Earth and get lost in boundless space like a balloon that broke free from its string. That's why it's so important to calculate everything correctly. Our heroes, like true scientists, know that for a safe flight, they need to know the formulas. Key formulas for circular orbit motion. We've already talked about speed and acceleration. Let's see how they can be calculated. Orbital period. This is the time it takes for an object to complete one full revolution around its orbit. It is measured in seconds. V2, where R is the radius of the orbit, and V is the speed of the object. Linear speed. This is the speed at which an object moves along its orbit. It is measured in meters per second or kilometers per second. V, T2, R, where R is the radius of the orbit, and T is the orbital period. Speed can also be found using the gravitational constant the mass of the central body, and the orbital radius V equals RGM4. Objects, hardo, objects, harrowed objects, 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 harder. An approximate formula related to the acceleration due to gravity on Earth's surface can be used. V equals R, GOR, dos, centripetal acceleration AC. This is the acceleration that is always directed towards the center of the circle and forces the object to move along a curved path. It is measured in meters per second squared. Acere bitos, where V is the speed of the object, and R is the radius of the orbit.
Problems for true astronauts. And now, to consolidate our knowledge, let's help Mickey and his friends solve some cosmic problems. Problem 1. Mickey Mouse's space station moves in a circular orbit around Earth at a speed of 7.9 kilometers per second. What is the radius of this orbit if the station's orbital period is 90 minutes? Given V equals 7.9 kilometers per second equals 7,900 meters per second, T equals 90 min equals 90 times 60, south equals 5,400 south, find R. Solution. We know the formula for speed in circular motion. V equals T2R to find the radius R. We need to express it from this formula. R equals 2 VT. Substitute the values. R にかける 3.14 7,900 meters S 5 4 O O R 6.2 8 4,266万 R 679万3000 meters are approximately equals 6793 km. Answer. The radius of Mickey Mouse's space station's orbit is approximately 6,793 kilometers.
Objective. To understand how speed and gravity affect movement in a circular trajectory. Materials: rubber ball, strong thread, or thin string. Plastic ruler or pencil stopwatch, tape measure or measuring tape, sheet of paper, and a pen procedure. Preparation: tie one end of the string to the ball. Wrap the other end of the string round a plastic ruler or pencil. This will simulate the gravity that keeps the ball in orbit, and the ruler is our observation 1. Changing speed. Holding the ruler horizontally. Carefully begin to spin the ball in a circle over your head. Pay attention to how it moves. Slowly increase the speed of the ball's rotation. What happens to its trajectory? Does the circle become larger or smaller? Try to decrease the speed. What happens now? Does the ball try to fall? Observation 2. Changing gravity. Spin the ball at a certain constant speed. As the ball spins, carefully wind a string onto the ruler, decreasing the radius of the circle. What happens to the ball's speed? Unwind the string, increasing the radius. What happens to the speed? Measurement. Choose a specific string length. Spin the ball at a constant speed. Measure the time it takes for the ball to complete, for example, 10 full rotations. Calculate the period of rotation using the formula V equals T2. You can calculate the approximate speed of the ball. Repeat the measurements for a different radius and compare the speeds. Conclusion. Write down what you learned about the relationship between speed, orbit radius, and gravity. How is this related to the movement of real spacecraft? Problem to Gufy's planet orbits. Its star in a circular orbit with a radius of 310.8 kilometers. It completes one orbit around the star in 250 Earth days. At what speed does Gufy's planet move? Given R equals 310.8 kilometers equals 310.11 meters. T equals 250 days equals 250 times 24 times 3600 south equals 216,000 south. Fin del fin. Solution. We use the same speed formula V equals T. 2. R substitute the values. 5 igual a 21.600.000 segundos. 2, 3.14. 3, 10-11 metros 5. 2.16. 10-71.884. 10-12 finto. 87.222 metros por segundo finto. 87.2 kilómetros por segundo. Answer. Gufy's planet moves at a speed of approximately 87.2 kilometers per second.
Well done. Now you know how Mickey, Minnie, Donald, and Gufy can safely travel around Earth. It's understanding how the world around us works, even in space. Who knows? Maybe one day you'll be piloting a real spaceship